Question is now, projectile in the preceding, right? Where,
That would be your velocity next.
write it compactly, R of t is 17 meters per second times I plus 10 meters per second.
I don't mean.
Booey.
We're only looking at the x direction though, so it doesn't matter about the j.
I'm sorry, I can't understand you.
We're only doing in the x direction, so it shouldn't matter if we have the j attached.
For the x direction,
It says we're only doing the x direction, so we don't need the j, right? The equal vector.
oh yeah, if you're just doing the x direction, I thought you were telling me the total. And I'm going to do something that you didn't do. Okay, right there's our position function, right? If I want the kinetic energy at 2 seconds, I'm going to bypass this question, assuming everybody got it, okay? The kinetic energy is the derivative of your r function. First of all, your velocity function is the derivative of your r function, right? Okay? Which is 17 meters per second times I plus 10 meters per second minus 10 meters per second squared t times j. I don't know if you can read that, but that's what it says, okay? Just take the derivative of this, okay? Now, if you want to know the kinetic energy of this projectile, you could find the kinetic energy in the x direction, plug in 2 seconds for t. Well, it's always going to be 17 meters per second, right? So kinetic energy is going to always be 1/2 mv squared for 17 meters per second for the x direction, right? Okay?
I did mine wrong.
So let's make that observation. Okay? 17 squared is 289. 3 times that is 300 minus 63. 300. 3 times 300 minus 63, right? 900 minus 63, which is 837 kilogram meter squared per second squared. Now check me on that, because who knows if I'm even right. That sounds about right. Okay?
You're 30 off, but yeah, you're right.
30,
Yeah.
couldn't be that far off. 89, oh yeah, yeah, it's 67, isn't it? Yeah, okay, I see. Yeah, okay, I know what I did. Okay, so anyhow, that's what we have, right? We don't need this, but we're going to observe it. Now, to calculate the kinetic energy at any point, kinetic energy is always 1/2 mv squared. What's v? Here's your v. That's your vector v, right? What do I mean by v without an arrow over it?
The magnitude.
Means the magnitude. Right? It's the square root of this squared plus this squared, right? I need a little more room. But the Vx is always 867 kilogram meters squared per second squared, or joules. I'm going to keep it with fundamental units.
If you see my card at my house.
But your Vy changes with time, right? So it's going to be this. Right? Makes sense? So you're going to just have one expression that you can evaluate at 3 seconds or 2 seconds or whatever, okay? Now, what it gives you is the same as if you calculated the x and y kinetic energies separately. Okay?
Is that t squared? Is that just t?
It's t. Let's see. Yeah, okay, I got carried away. I was going to square it here, so I just squared it there. Okay? Yeah, when I got a t to the fourth, I'd have realized that. That's something stupid. Maybe. Okay? Then you want to simplify that and use it. Okay? Because you don't need to calculate these two separately. You're going to have one quadratic function under the radical.
You also put in there the joules